And we've had, we've been consulting and doing analysis and contributing on several other passive house projects in this climate region and others.
Where's the first one located?
The first one is in Willow Glen, and we're going to go, we'll go over that project. So,
we have one more question here.
Yes, sir.
What's the difference between passive house and net zero energy?
Okay, I'm going to cover that. And so right now we'll talk about a plan, okay? Because we've got a big.
I have a quick question.
Yes, sir. Yes, ma'am.
Net zero, is it pre-solar or?
We will get to that. And here's.
So when you say net zero, how should I say thing? Is it?
Yeah, we'll get to that.
We'll get to that. So here's our challenge. As always with presentations, we have a room of about 60 people of mixed backgrounds and so forth. We want to meet everyone's objectives, so to speak, but it's challenging to do that. Let me give you the plan, and then we'll sort of together figure out the pacing of this. This is sort of the idea at this point is I'm going to talk very briefly about the context of building performance and building science, what it is, sort of where we are, the vocabulary, et cetera, to set the background. Then specifically talk about the passive house strategy, which is a design framework, standard, what have you. Give you the history, which is fascinating, at least to building science geeks like me, principles, the tools to make that design framework work. And then as David mentioned, we have two projects that we were partnered with the Building America program and the Department of Energy. So we have two projects, one new build and one retrofit, that we have really good data, performance data on, so that we can see, does this really work? And then finally, we'll sort of break for a minute. David will introduce the people that were involved in this project, and we'll talk about the MAGIC project. So how about an hour? Is 60 minutes total? Does that sound about right? Okay. Bronwyn is really good at cracking a whip and kind of keeping me on track. So she'll be giving me signals, and I think we're just going to stop and ask everybody, well, how's the pacing? Are we too slow? Are we too fast? We want to make sure that everyone's accommodated here. All right, here we go. So to begin with, building performance. It's actually sort of a new idea, or I should say the vocabulary is sort of new. So this is was built in this is a dry stack stone building in Ireland, circa AD 800. According to Building Science Corporation, this would have pretty thick walls. It had an R value of about 2. Okay, fast forward 1,200 years to a typical glass office building. Okay, R 1.5. What's going on here? It's actually 50% less efficient than that building that was built 800 years ago. What is going on here? Okay, this is glass curtain wall. This is sort of your typical striper. They're everywhere, and they're going up all the time. Okay, but it gets better. We can actually build worse buildings, right? Because we take a glass cube, okay, that has an R value of 1.5, and we can lower that. We can lower that by, here's the thermal image of a, let me see if I can use the fancy green pointer. This thing really, we can put fins on it, right? We can put concrete deck extensions, not thermally broken, okay? And we can really create a cooling tower, if you will. According to Dr. Stieberich at Building Science Corporation, his quote was, "This is a thermodynamic obscenity." Okay? Really stupid, okay? But we're building them. This, I would point out, is an award-winning building, all sorts of awards, and it's LEED certified at the same time, okay? A horribly performing building, but this is what we do. Now, why should we care? The Energy Information Agency of our government says that 42% of all the energy we use in our entire country is used in buildings. And we build today, this was completed in 2009.
Sorry, I think you just asked a question. What LEED certified?
LEED, Leadership in Engineering and Environmental Design. It's one of the top green or sustainable building standards. Okay, so this is the background, all right? And the vocabulary of building performance is something that we really don't, in the common parlance think about. Okay, so we mean building characteristics, the characteristics of the actual asset, right? How energy efficient it is, you know, the quality and durability of the building, how simple it is to operate and maintain, and sort of the life cycle plan. That's the characteristics of the building. The other thing, though, is what about the occupant experience? The health, productivity, and comfort of the people that use the building, the indoor air quality, how comfortable it is to be in, and acoustical comfort. These things are really, both of these classes of building performance criteria really do not, are not part of our culture in this country anyway. Okay, so buildings that rot, we build those all the time. Okay, here's an example. This is sort of supposed to be a high-performance building. They didn't understand the physics and the science. An unvented roof assembly that couldn't dry, had a terrible vapor profile, condensation, boom, rots. Okay, this over here actually is was one of my colleagues' building here. This is California, folks. This is supposed to be a really easy climate. Buildings still rot even in California. This is a standard detail of oriented strand board in building sheathing, and with building paper and stucco all smashed together. So it gets wet, there's capillary action, the assemblies get wet. If there's any kind of leak, for example, in windows and so forth, the OSB gets wet, it gets saturated, and there's no drying capacity, so the buildings rot. So this goes on. There's billions of dollars of construction defect litigation that you don't hear about much, but it goes on every year, all the time, because we don't have a culture of building performance, okay? The inside stuff, how we feel in our buildings, indoor air quality, thermal acoustical comfort, okay? We rarely articulate these criteria when we go to design and build something. Almost never, certainly not in residential. Maybe hospitals and so forth, okay? In spite of the fact that there's all sorts of great science and literature and standards to do it. It's there, okay? So we have the science and technology. That is not an issue. There's all sorts of organizations, knowledge and best practice, Department of Energy, National Renewable Energy Labs, Oak Ridge, Lawrence Berkeley, ASHRAE, all sorts of other professional organizations, Building Science Corporation, Passive House Institute, and many, many more. We have the knowledge about this stuff. We have tools. We have energy simulators, thermal heat flow analyses tools, hygric response tools, Passive House Planning Package. We'll talk about that. Okay, so we have the tools as well, and we have all this sort of neat technology. We have engineered thermal breaks, we have low E windows, we have all sorts of really nifty products. So there's no excuse, in other words. What we're missing is the culture of performance. It's all low bidder, thinking about short-term, not long life cycles for buildings. We could talk forever about that. But that's the problem, is we don't have a culture that values performance in buildings. Okay, so what strategies are available to address this situation? Well, one that we're going to talk about, the major focus of today, is this framework called, the standard called Passive House, or I would say energy balanced buildings. And we're going to talk a lot about that. It focuses on the shell of the building, making it efficient and conserving energy. Surprisingly, it's not the new thing. It's actually a very old thing. It's 40 years old, okay? Started here in North America, of all things. There's the book that was published in the 80s, okay? It was abandoned in the 80s, as you'll see when we go over the history, for politics, policy, what have you. And unfortunately, it was adopted in Europe, and so it was not lost, and now it's a scientific design framework. Okay, now, net zero energy, think about it as passive house, okay, super low energy, super efficient buildings that conserve energy. Add renewable energy to them. Hopefully you can produce as much as you use or thereabouts, and you have what we term a net zero energy building, okay? And this is also gaining traction as a concept because it's a really simple, elegant, wonderful concept. Gee, produce as much energy as you use. What a thought. And so there's California law, Assembly Bill 32. There's a lot of work that's going on that we're partially involved in with Public Utilities Commission, figuring out how to move this standard, this concept into our building performance culture. Very challenging to do. Okay, so we're going to talk specifically about passive house primarily. And you'd answer, okay, why? What's all the fuss about passive house? All right, first of all, it exists as a very rigorous international building standard. It exists. It's really the only one that has a standard that's that rigorous. So that's the first reason. It's very simple, elegant principles. Love simplicity. It articulates the concept of thermal energy balance, which is one of the things, in a very rigorous way. You'll see, has an amazing modeling tool that goes with these principles called the Passive House Planning Package we call the PHPP. Well, it actually works, and we'll show you the data from it. It works as advertised. But my favorite, not listed here, the one reason that we really like to build passive buildings is that we can actually heat them with a hairdryer. There's the hairdryer. They are so efficient, they can be heated with a hairdryer. So, what could be more fun than that? All right, so a brief history of superinsulated buildings. So you get a context, because again, the important point here, people think, oh, passive house, and isn't that European, strange European thing? What do they know? Where did that come from? Well, actually, it's quite the opposite situation, although I have to give here, I'm urged to give the first one, the first net zero energy building on the planet was built in Denmark, near Copenhagen. A couple of engineers at the University of Copenhagen, 1975, the Lyngby House, quite famous. It's got all sorts of thermal storage. It's very exotic and so forth. It was sort of a one-off deal, but they received an award at the last International Passive House Conference. Most of the work was in the United States and Canada, in North America. So, first one that was actually designed was the Locale House that came out of the University of Illinois in Champaign-Urbana, 1976. Plans, the Saskatchewan Conservation House, Harold Orr, Rob Dumont, Saskatchewan Research Council. It's cold in Saskatchewan. What, 12,000 heating degree day? Okay, there was, okay, and remember when this took place, 1977. When was the oil price? 74. You'll see when we go forward. Very significant. The Ledger House in Massachusetts in 78, Robinson House in 79. You get the idea. Lots of these in the late 70s in North America. Okay, and why? What happened here? Passive solar. You'll think, you probably came here expecting to hear me talk about passive solar. Okay, well, the problem is they only had one slice, they had one variable in a longer equation that they were focused on. And we term the approach mass and glass. Lots of glass. Let's just suck all that solar energy we can, store it in thermal mass and Trombe walls and so forth too, and try to recycle it and blah, blah, blah. Okay, but it didn't deliver. The guys who tried to do it in New England, they were all freezing their ass off, right? On cold winter mornings, right? Before the building heated up. So this happened in the 70s where you really started, the idea is the basic focus was on the shell or the building envelope itself, and not just the solar part of it. So there were a couple of books after the work in the 70s, 81. This was William Shercliffe, physicist at Harvard, and then a couple of the other guys, the research engineers and so forth. Superinsulated Home Book in 1985 was published. So these were built, these were researched, they were analyzed, they were formulated data, the books were written, the technology and the ability, it worked, okay? They focused on the shell. Superinsulation. Thicken the walls. Come on, don't be skimpy with the insulation, right? Avoid thermal bridges and bypasses. Don't let the heat escape through, unbroken, concrete slabs that extend out into the exterior. Triple pane windows. Add another board of glass. Come on, the windows are the weakest part of the envelope. The average window, double pane window, has an installed R value of 2 or 2.5, even in today's technology. So let's make these better, make them airtight. Get rid of the unwanted infiltration and exfiltration of air and heat. Okay, when you ventilate, we need fresh air. So let's use heat recovery, simple. Let's just exchange the heat from the exhaust air to the incoming air, temper the incoming air, and don't lose all that precious thermal energy, right? Direct solar gains, yes, but be modest about it. It's only one variable in the equation, okay? And lastly, this was highly successful, okay? The data from this was, you know, people in Saskatchewan had $100 a season heating bills, and they used to be $1,200. So it really, really worked, okay? I thought this quote was interesting. This is William Shercliffe. He's famous. He was on the Manhattan Project, and then he was a physicist. He published this one book here. He basically said, they're so simple and inexpensive, fully understandable, so very simple and understandable as to be no fun. He thought they were boring. Okay, great.
Before you go on to the next story, I'm going to break a quick technical thing. We're having a sound issue. If we could just fix that before we pop into the next.
Are you?
There's a little, like, when we did sound check, it was great. Right now, there's a little bit of feedback. I'm wondering if, like, all the cables are in.
Cables are in. I'm getting.
I want to remind you that he's posted his PowerPoint online. You should have received an email with that link. If you didn't get it, email me and I will get you the link.
Well, but it will be there next week, because I was, you know, late at night last night, you know, finishing things. You know how that goes, huh? How we do? We have 17 minutes elapsed. That's not bad. How's the pace, everybody? Are we okay? All right. Okay, so let's put this history, let's broaden the history, not just houses built in Saskatchewan and